going to look at the test and go, oh my gosh, looks exactly like the practice test did, just with a few different numbers. That's it. So number 1 says, oh, I better hit record. I already did. 343 x to the 6 y to the 12th over 64 x to the 3rd y to the 6th all to the 1/3 power. How do we start? You could, to try to reduce the fraction, you could. Megan? Couldn't hear you, Megan. It is going to be cubed root. So yeah, we kind of have to figure out what to do. You know, if you're looking at it and thinking, I don't know where to start, always think order of operations. Normally we do everything in the parentheses first. So let's start it by checking out 343 over 64. Let's see if that reduces, if we can get a nicer number out of that. So calculator, 343 divided by 64. Math number 1, rats. All right, so we're stuck with 343 over 64. We are not stuck with 2 x's and 2 y's. We're not. Because this is division with similar bases. What do we do with the powers if we're trying to divide? We do subtract. What is 6 minus 3? 3. So that's a positive 3. That's going to go on the top. Any positives are going to stay up on the top. How about the y's? What would we get?
6.
Positive, it's going right there. And then, great that Megan remembered this, 1/3 power is cube root. That's what it is. So what we really want to do to all of this is take the cubed root. But if we do that as one big fraction, everybody's going to go, what the heck am I going to do with that? So we're going to do it individually. Find the cubed root at the top. Stop. Find the cubed root at the bottom. Stop. All right. Cube root of 343. Now, you're going to have your calculator for the test. You could certainly start thinking, okay, well, obviously it's not like 2. That's too small. So you could think, well, 5 cubed is 125. Maybe I ought to try 6 cubed. You've got calculators, punch in 6 cubed. Tell me if it's 343.
It's not.
Cubed root 343.
7 words. Perfect.
Yep.
7 is just beautiful number. And 4.
It wasn't 6. What was it?
7.
It was 7.
X third y. 6.
Okay, hang on though. It's not x to the 3rd if we take the cube root.
X.
What do you do with this and this? Yeah, you divide. So 3 divided by 3, x to the 1st.
So just y squared.
How about the y to the 6? Y squared. 6 divided by 3 is 2. Cube root of 64? 4. And then for our final answer, we just wouldn't put that 1 up there for x to the 1st. We know we don't need that, so we just make it 7xy squared over 4. Please be quiet.
Okay.
Jeff asked me to speak loud.
All right, number 2. This time, there's nothing we can do in the parentheses. So we have to think about what's going on outside the parentheses. Give me something you see that will be helpful. Negative power. What do negative powers do?
Flip it.
Flip it. So we need to make this 1 over 128. And now some people will put the negative on the 128. Some people will put it on the 1. For me, it always looks goofy to have it on the bottom. So I would put it on the top. It doesn't make any difference. You just put it in one spot. You never put it in both, because if it were there for both, it'd be a positive instead of a negative. Alrighty. 3 7s, huh? One of those is the index for a radical. Which one? The 7, the bottom one. So what we can do is we can take the 7th root of negative 1 over 128, and then we can cube it. But again, this is a fraction. So don't think about it as a fraction. Say to yourself, self, I'm going to split this. So we took that 3/7, we took the 7 off of it by taking the 7th root. Now what number, remember 7 slots sitting in front of you.
2.
For -1?
No, for what? 28.
Okay, you're already a step ahead.
Yeah. It's gonna stay the same.
Okay. Now we have to cube it. Again, don't think of it as cubing a fraction. Cube the top and cube the bottom. -1 times -1 times -1 is -1. 2 times 2 times 2 is 8. And we have it. That wasn't too bad. Number 3. A to the 1/6 times A to the 2/8.
Gotta get a common denominator.
We do. Yeah, we do. We have to get a common denominator because we need to add those. When you multiply similar base, it is 24.
Yeah.
So let's multiply this one on the top and the bottom by 4. And this one on the top and the bottom by 3. So A to the 4/24 times A to the 6/24. A to the 10/24, and then we have to check to see if we can reduce.
A to the 5/12.
A to the 5/12. Now we might be done. Here's what we have to check. Go back to the original problem. Did it have fraction powers?
Yep.
Well, then we're done. If it's radicals, we have to write it as radicals. If it's fraction powers to start with, then we leave our answer as fraction powers. Number 4 has lots of steps.
Great.
Yeah, Jeff.
For the test, if we write it as it'd be
The 12th root of A to the 5th,
yeah.
you'll lose half. Lose half. Whatever they gave you is what you're supposed to give them back. So always do that last check. Oops, I got too many X's up there.
27X,
Hang on,
27.
27X. Here. What
Not too much.
do you think?
Flip it.
Flip the whole thing?
Oh, yeah. Quit.
You want to do that right away?
Oh, yeah.
Okay. Got to get rid of those negative exponents. They are killers. Right, but I don't flip the whole thing anymore. Just the x to the 3rd comes up here. I said it and didn't write it up there.
It's all cube.
Now what? Not done. What?
It's all cube.
It is cube rooted. All of it is cube rooted because this 1/3 power is for cube root. Test taking strategy. Didn't we do a cube rooted one up there earlier? Number 1. So if you get to this one and you go cube root, you do that again. You look at number 1. Boy, that's right. So cube root of x to the 3rd over cubed root of 27y to the 6th. Cube root of x to the 3rd is?
X over the right.
Cube root of 27? X over 3y squared. Everybody solid with that one?
Yep, that's the
Yeah.
answer.
I got that one.
All right, let's go to number 5.
This one hurts my brain.
Wow. Ideas?
You gotta multiply the bottom.
By 6 digits.
No, that was 6, 1, 6, 2, and 6, 3.
I'm lost.
Oh,
Or,
you change, you
I don't
flip it
think-
to front.
You can tell them in a second. Test taking strategy. Look at everything on the first page. Do you see radicals anywhere else? So Nick, what do you do?
Flip it to the fraction. So
Change it to
16
fraction powers. Change it to fraction powers. When you get to this, you should go, wait a minute, this didn't have there's no radicals in here. This section was about fraction powers. But now what do we need?
Common now.
We have to, yeah. Because what do we have to do with those two powers? Subtract, yeah. So 3 and 4, what you got? 12. That one's going to need a 4, top to bottom. That one's going to need a 3. Six to the 1/12.
And then you gotta put
Beautiful. We do have to put it back in radical form because that's how it came to us. So we work with the fraction powers all the way through, but then when we get done, we put it back.
you have to put the 1 there to the
Yeah, this is 12th root, so we have to have the 1/12th, and we have to put the 12th root.
No, but like do we have to have
That's as simple as we can make it. Absolutely. Simplify what's in the parentheses first. It makes this problem very basic. 2 minus a -8 is really 2 plus 8. And we haven't had to do this yet. What do you do when you raise a power to a power? You multiply. So you have to think of this as a 10 over 1. With fractions, it's always top times top, bottom times bottom, and then reduce if you can. 4. That's it.
simple?
That's it. All right, now we're solving.
So
This is where
Now, notice the directions. Solve each equation, check for extraneous solutions. So we need to know extraneous means those false answers. You know, we do all the math right, get this answer, and it still doesn't work. And the key to this is, the book always said isolate the radical, get the radical first. Already is, isn't it? So how do we get rid of it? We square both sides. Works out really nice on the left. But we can't distribute that power to on the right hand side because if there is subtraction or addition in here, you can't do that. We actually have to write it out twice or remember the shortcut that I taught you in class. But most people don't remember the shortcut and you're really good at FOIL. So write it out twice. FOIL. Outside times outside. -18x, -18x. Total of -36x. Somebody in here knew 18 squared. On the roll, and did those powers. It is.
that's
proud of you.
no, it wasn't like that. Oh my head. It doesn't say 18.
Ideas? It has a squared, it has an x, it has a number. Yeah, we gotta move them over. This is a quadratic. Quadratics get solved by finding a 0. So let's move them over. Have a 0. We have a quadratic. We find the solutions. The opposite of FOIL. Factor. We're going to factor. We need to see how does this break down. I got good news and I got bad news. Well, the good news is it is factorable. Bad news is we have to find the numbers that multiply to 322 and add to -37.
Wow. Can do that in 2 seconds.
So, let us know if you find it. We're looking for
Point
two
one.
numbers that go into 322. Nice, you already got it, Megan? 7 and 46? Well, that's gonna be 39, you're close.
Oh, yep. So close to those. It doesn't exist.
Yeah, it definitely exists.
Ah, ding, ding, ding.
Yeah, Nick.
Why is there a point to doing
Takes
all
a
that
while.
guessing checking just to do one problem? It's stupid.
Because it's math.
Attitude
I'm
problem!
sorry, but like it's just like I don't know. It makes sense when you're just solving it and you get an answer. Now when you have to get a bunch of decimals first. and
Okay, then here's what you could do, Nick.
Ah,
You could do the quadratic formula with 322 in the formula. That is nasty. It'll get you the answers, but it is nasty. So x minus 14 and x minus 23, what does that mean our solutions are?
14, 23.
14 and 23, because if you put 14 in here, you're gonna get 0, and if you put 23 in here, you're gonna get 0. But we had to square both sides to get this answer. It's quite possible that one or both of these will not work. So back to the original we go to show that we checked our answers.
These aren't very fun. 14.
They are fun.
I have fun.
They're little puzzles. So 14 plus 2, 16. What's the square root of 16?
4.
What's 14 minus 18?
4.
Oops.
Whoops.
That one's out. We have to show this so I can see, hey, they did do the checking. The other one, 23 plus 2 equals 23 minus 18. 23 plus 2, 25, square root, 5. 23 minus 18,
5.
good. That one checks.
Don't
Sweet.
So we make sure that once we find them, once we spent all that time finding those factors, we want to make sure that's going to work. And show the math. Show the math as you go through it. Number 8. What do you think?
Give up.
multiply by 2. Or wait. Yeah, good job.
You do multiply by 2, but what are you really doing when you're multiplying by 2? You're squaring it, because we're going to raise it to the reciprocal power. So 2 times 1/2 is 1. This is going to be 2x plus 1 equals. And then on the other side,
25.
and this is the part that makes me think something's wrong. You
It's
notice
not-
how we just took a negative and we just made it positive? So it's quite possible whatever we get here is not going to work anyway. But we'll just keep going and see what happens. Because you guys know how to do the math from here, right? Subtract 1.
If we put that on the test, it doesn't work, like we stop going and it's right, is it right?
It doesn't.
We wouldn't have had to do any of this math if you looked at the original problem and you knew.
Yeah, so if we
This
do that,
says
if we know on the
The
test.
square root of 2x plus 1 equals -5. There is no way that a principal root equals -5. And you could stop right there and
So we
say,
could just say no.
principal root will never equal a negative.
Could we say
Don't
no?
Nick just got.
No, not no. You have to
So we could
explain
just
why
say
you're not doing
principal
it.
root doesn't.
Principal root will never equal a negative.
So we could say that and get full points.
Oh, absolutely. Absolutely.
Alright,
Because
sounds-
that's a deeper
sounds
question than going through and finding this. And like I said, I don't think this is gonna work, so let's take a peek.
Alright, well, let's figure it
2 times 12 plus 1 to the 1/2 power equals -5. 25, and the square root of 25 is 5 for the principal root because they didn't have a minus up here. This means they're saying they just want the positive one. It doesn't work. 5 does not equal -5. So this has no real solutions. No real solutions.
Can that be abbreviated by NRS?
You're so lazy.
Ah.
It's just.
And now that's on
Really
recording
means no
for
real
all
solution.
posterity. Alright, number 8, you got it? Let's look at 9. Is the radical
Don't say
isolated?
that.
Is it isolated? Is it by itself?
No.
So how do we get rid of cube root?
You ruined it.
No, it's already cube root.
Cube it.
Cube it.
Yeah. Put that finger down.
What's negative 2 times negative 2 times negative 2?
Negative
Dude, you are smart. What?
Solve it from there. All right, everybody. I am not as worried about this answer as I was the last one. How come?
This is wrong.
Because it's still
Cubing.
negative.
It's not squaring. It's not an even power that we raised it to. But yeah, we do have to check it and make sure. So we'll go back up here to the blue.
It's right.
2 times negative 2 minus 4. Does that really equal negative 2? 2 times negative 2 is negative 4. Negative 4 minus 4. Cube root of negative 8. Does the cube root of negative 8 really equal negative 2? Cool. There's our check. Right there.
How many points is the check worth?
1. For each problem.
Well, I'm gonna get about
Alrighty.
points out.
Now,
Yes.
I need your attention because we are entering the land of the most missed problem on the test.
Put it on the test. Check. Yeah, just check mark it.
This one hurts my brain.
No, it doesn't work out.
Don't you
Wait,
see
check
it?
next. You have to divide the 2.
You do.
Ha!
Has to be isolated.
So freaking smart.
I don't know about that.
Guess what I do? So I don't care.
You should.
What do you think?
Yeah, square it.
But you
You
keep
gotta
running.
prove it.
Well, we actually have to kind of do both.
Yeah.
You have to raise it to the reciprocal power.
Why would you cube? This is-
I saw that. I wrote.
Now.
I'm sure you did.
On the left-hand side, x minus 2. However, the right-hand side is the piece everybody misses. We just raised this to a power that has an even number on the bottom. That even number is like taking the square root. What's the square root of 25? And
-5.
that's why the book made us do this when we did these problems, so that we didn't forget. There's also going to be a positive and a negative on this one.
Hold up, I have a question.
Yep.
So does it just be like any, what's that thing called, even, or does that have to be 2?
Any even denominator.
So if I got like 12, it would be like,
You still would have to do the absolute value with the plus or minus. Now, some people don't do the whole absolute value thing. Some people do this. They get over here to x minus 2 and they go, but wait a minute, that would be plus or minus 5 cubed. So that's going to be plus or minus 125. So I'll just set this up to negative 125 and positive 125 and get it.
And they're wrong.
But that's what absolute value makes us do, is set those two up. So if you can get it by thinking your way through the square root piece over here and do it this way, perfectly fine. If it takes this point where you say, oh, wait a minute, that means there's 2 of these, because square root of 25 is 5. 5 cubed equals 125. And now, absolute value, remember prison bars. We need the 2 jailbreaks. We've got the positive and the negative. So we end up at the same place as somebody who just said, oh, square root, that's going to be positive and negative. And if that's what's happening, I'm going to need to make sure I do plus and minus. 2 times we need, write it down, we need the square root, 2 times negative 123 minus 2 to the 2/3 equals 50. And you could just grab your graphing calculator and make sure this comes out to 50 and put GC check, on that one. And then the same thing with the 127. So it'd be 127 minus 2, 2/3 equals 50. Because most people probably won't want to say, oh, negative 125, the cubed root is negative 5, negative 5 squared is 25, 2 times 25 is 50.
Couldn't we just do the GC check?
Well, see, then what's gonna happen is I'm gonna have to take off double points for when it's not right, and you put GC check on it. You lied to me. You didn't check it.
Yeah, but you can't take a
What if
points
you
for
actually-
lying.
Sure I can.
How?
What if you
That's
actually
not
do check?
What did
it?
you say?
What if I check it just look at
Well, that's not good.
Yeah. What if we mess up on the check?
Okay, we need to keep going.
Yes.
This is f of x and g of x.
Yeah.
11 says we are supposed to divide.
I think that's
Strap.
So we divide.
Well, I'm always strapped.
Is there anything we can do to cancel?
No.
No. There's addition and subtraction here. So the only way we can cancel is if we can factor that numerator. Are there two numbers that multiply to -3 and add to 0?
Oh, no.
That's done. Now we go down to the domain. The domain, we restrict that whenever we see that we're taking a square root, 4th root, 6th root. That's not here. Or there's a possibility we could divide by 0. There is a number we have to leave out of this one because we are dividing.
-4.
So -4, because -4 plus 4 would give us 0. So x can't be -4. That doesn't matter. A 0 in the top is fine. We can do that. That's 0. But dividing by 0, can't do it. Number 12.
Wait, that's all?
That's the domain.
That's it?
Okay, hold up.
So,
Ain't it the same question?
Same type of question for number 12, but we're subtracting. Now, that means we have to distribute that negative. We have to, because it's like a -1 times everything in those parentheses. And then we'd simplify x squared minus x minus 7. Domain. Hang on 1 second. Did we ever take square roots, 4th roots, 6th roots, 8th roots as we went through this problem? Did we divide by anything? The domain is all real numbers. There, it's not going to be there. We have to know it's there, Madison, by knowing that a negative in front means -1 times everything back there. Emmanuel,
Never mind.
or did I just explain it?